We I was saying that nowadays it's very difficult to get the right candidate selected in an interview.
You were interviewing someone?
Sorry?
You were interviewing someone?
Yes, I was interviewing. Like I interviewed 3 people this morning and none of them are good.
What is the post?
The post is for performance lead. You know performance testing?
Performance test.
Application performance testing. It's very related to this. So, like we need to have the process performance improved for the application, and for that we need a performance guy who knows the how to work on JMeter, Load Runner, SOAP UI, Postman, all those tools. And the guy was around 8 years experience and he was not able to answer any questions. So I said, come on, I what to do. Anyway, so today what we are going to start is something called a Hadoop and Hadoop ecosystem. HDFS stands for highly distributed file system, okay, or Hadoop distributed file system. So as you have C drive, D drive, right, in your machine, similar to that, you don't have a normal C drive, D drive in Hadoop file system. So Hadoop follows a specific type of file system to read the data and write the data inside that. Right? When I'm talking about Hadoop file system, we are talking about huge amount of data to be written or read from the system where it is getting stored. Okay. So there are some link which you can read it. This is an updated PPT. I will send it across to you all. Okay. So Hadoop ecosystem. So it's a little bit of a background history. So Hadoop ecosystem, Hadoop is a technology to store massive data set in a cluster of cheap machine in a distributed manner. It was originated by Doug Cutting and Mike Capella. Okay, so these two guys actually developed the system. Hadoop is de facto industry standard platform solution for big data technology. Due to unfriendly user interface, that is command prompt, there is a need to develop additional component that allow easier communication with the end user. The result of these efforts is a Hadoop ecosystem. So when the Hadoop was first developed by two people, right? Those system was very much a programmatic way of doing it. So you had a black screen and then you have to write everything. Okay, pick up the file, drop the file, copy the file, and all those stuff. It is very difficult and people don't like to write so much of text. It is better if you drag and drop, if you use some tools that can help you to do basic stuff. In that case, Hadoop was developed and it was developed in a form of an ecosystem. I will explain you what is the ecosystem. These ecosystem components are different services deployed by various enterprises. We can integrate these work in a variety of data. So think about an ecosystem is a group or collection of different software together. Okay, so let's say for example, in a very basic example, if I want to give what is an ecosystem is, you work in an organization or a company, right? Let's say you are all students in Seneca, right? You use Word document, right? Word as a software to document it. You use Excel, so that's a Microsoft product, right? But you also use some software that is given to you, right? So let's say college is using Oracle as a database. College is using .NET as a software. These all systems are form of an ecosystem. They are collectively used within the enterprise, right? So they need to be connected to each other in order to solve a problem. So Hadoop distributed file system was only storing the data. How would you read the data? For reading a data from a database, you need structured query language, SQL, right? Similar to that, in order to read the data from Hadoop, you need a language. That's a query language. Either you use NoSQL or something like that, which can read the data. Now, there may be requirement where data needs to be published in a report. So you cannot write code to publish it. So you need a tool to help you to get that data to be reported in a form of a reporting tool, right? So there needs to be a system where each and every entity can be used in a different way to get the outcome. So that's an ecosystem. Each of the Hadoop ecosystem component is developed to deliver explicit function. I will show you how that is done. And each of it has its own developer community and individual release cycle. Officially, Hadoop ecosystem has 15 components and it's progressing extended. Okay, so this is a Hadoop ecosystem. When I say Hadoop ecosystem means it's a group and collection of software which are in tandem, jointly together in order to achieve some goal. For example, Hadoop does this. You see this Hadoop distributed file system. This is only Hadoop. But what happens is if I have to read the file and write the file, I need something over it, right? So what did they develop? They developed something called as, if I have to read, I use Hive. It's a query language. Like a database, if you want to read, what do? You write a query language, right? You write a procedure, you write stored procedure, you write select statement updates. Similar to that, in order to read the data from Hadoop, they develop a software called as Hive, which sits over it, right? There is something called as Zookeeper. Zookeeper, as a name suggests, what does a zookeeper does? In a zoo, when you go, what does a zookeeper does?
Take care of
Animals, right? Similar task zookeeper does here. It monitors and see what's going on and how it's being worked out, right? So that's a more of a monitoring type of thing. Okay. There is something called as drill, Apache drill. That's again a package or a component that sits over Hadoop, right? It's more used for machine learning programs. Okay, so your data reside here, but I need some machine learning program. And when we'll discuss about how machine learning works, I will tell you how the machine learning is used. I will not teach you this language, but I will teach you how the machine learning programs are written. Tomorrow, when you go to any organization, maybe if this software is not there, some other software is there, concept still remains the same. Okay, maybe the syntax will change for you. There is something called as Avro. Avro is a format of JSON. So you know services, SOAP service. Everyone know about SOAP service? Web services, you know? It's an API, right? Which is being called. So you have SOAP service, which is a traditional way of writing a web service. Then you have a newer version called as REST services, which has got get, put, post, patch, delete statements, functions, right? Then the advance of REST services, JSON service. Advance of JSON services, your GraphQL. An advance of GraphQL is designed on a schema called as Avro. It's a formatting way of writing JSON. So if you have to read the data from Hadoop file system in a form of a JSON, you need some tool, right? So that's one software. Then you have HBase. It's the HBase column store. In our organization, we don't use HBase. We use a software called as MemSQL. Okay, it's also called it's used to call MemSQL. Now the name of the product has changed. It's called a single store. So basically, what it does is the concept of column store and row store comes into picture. So when you want to store a data, so let's say you want to store a file in your computer, what do? Save as, right? Save as, and then you give the directory path where you want to store, right? Let's say I want to give you an Excel sheet which has got 10,000 records inside it. What you will do? You'll do Control S and save it as particular drive and directory, right? When you want to store a data in a folder structure in your machine, where does it get stored? So there are two types of memory in your laptop, right? One is disk, where the data gets stored, and the second is the RAM, which you called as main memory. Main memory is RAM, and the backend memory or disk memory is your hard drive or SSD, right? So when you install an Oracle on your machine, or when you install a SQL Server or any database on your machine, so you give program files, it will get installed there, right? So let's say you create a table called an employee table, right? Employee table column ABC, and then you save that table, and then you do insert statement, insert into employee table value equal to this. Where is data getting stored? Doesn't get stored in it, gets stored in the disk. So let's say tomorrow your laptop get crashed, you take out your disk, you put it in another laptop, you will still have the database, right? So it's stored in disk, not in RAM. RAM stores only the data which is currently needed by the operating system. If you shut down, it's gone, right? It's gone, right? It's not persistent. So whenever you store the data in the database, it gets stored on your disk. Now think of a scenario where, okay, next question I will ask you is, which is faster, your disk or a RAM?
RAM.
RAM is faster, right? Everyone knows it, right? RAM is faster because it reads from the main memory, it gets read. If anything has to be read from the disk, it has to go to the disk location, find the sector in the disk, and then read it from there, right? So there is a latency involved when you are reading it from the disk versus the latency. So you have a scenario where your application needs a data in quick time, like in millisecond. So you need an API to respond in 200 milliseconds. If it starts to, or 20 nanoseconds, can it read from disk? Not be possible, because it will go, if I'm talking about data which is around 20 terabytes in your store in a disk, if you go and read, open the file, it will take 2-3 seconds to read it, the data coming out from it, if your database is not so big, right? So what happens in the business world, there are data which is needed to be read very quickly. You cannot wait. Like for example, if you are trading in a market, if you click on buy a stock, it should not take 5 seconds, because if it takes 5 seconds, the rate has changed, right? It changes a fraction. So the data which you need in a quick time to be retrieved and shown to the user, that data need to be accessed faster, right? And the data which you don't need frequently, let's say you want a report for an annual report. It takes 4 seconds, 5 seconds, doesn't matter. If we can read it from the disk, right? Because it's not urgent, it's not changing. Then the concept comes columnar store. So any transaction data which is readed in a quick time, you store the data in the main memory. Right? Any data which is analytical, any data which is related to reporting, you store it in the disk in a form of a column. Any data which is needed in a real time, that is stored in the main memory, called as row store. So same thing, Hadoop file system stores the data. Whichever data is needed for the quick time, you create a table in a way that it gets stored, these tables in the RAM, these table in the disk. So if it is needed for a quick time, data can be picked up quickly from the main memory. If the data is needed for a little bit latency, we pick it from the disk. All that concept comes here, called as HBase or a single store. So you will use it, because when we started building databases in 90s and 2000, we had a normal one database, right? You have one database installed on your machine, you'll create a lot of tables, you'll create procedure and execute it. Then the concept start coming, okay, we'll use cluster database. We'll have one database stored in the cluster, right? Partitioning. Then the concept come, okay, still it is not efficient, we'll store this in a cloud. So every database was stored in the cloud. Now the problem comes, when you stored it in the cloud, what is the efficient way to read it? Then they started storing that, okay, data which is needed frequently for online transaction processing, we will store it in the main memory of the cloud machines, and data which is not required frequently we stored in the disk, right? So that's a column store.
Sorry, so the column store is include both short term and long term.
Column stores are basically to store data for long term,
Okay.
which you don't need frequently. Row stores are data which is needed frequently on daily basis, every minute, every second, right? So any online transaction processing system you will go, which changes the data very frequently, they will start again. Single store is one of the product in the market. There are many companies, right? They build this type of solution. Okay.
This is for the long term. So for
When I say long term, short term, don't think about long term, short term. Think about, I want to get a customer name and I want to get full quickly name. I will store that table inside a main memory. But if I need to know the customer's whole history of summary, I'll keep it in the column store
okay.
or the disk, because not frequently you are requiring the customer full information, right? So like in your database, you use primary key, right? Primary key, foreign key. In single store, you use primary key, foreign key, but something which is used here is called a shard key. Okay, it's like a pointer to a memory address. If you have studied C, C++, you know, pointers, you know, right? You have studied C, where the concept still remains the same. So you are storing the data in the disk, in the memory, main memory, as a part of an address location that is reported by shard key. Okay, again, outside of your scope, but again, this is a background of it. There's something called as YARN. YARN is called as yet another resource negotiator. Yet another resource negotiator. The job of YARN component in Hadoop is to negotiate with the other machine how the resources will be used. So last time, if you remember, I explained you about distributed systems, right? One is called as master, other is called as slave. right? So Hadoop works like this. You will have a master, right? And you will have slaves. Okay, these are slaves. Okay, these are slave machines. Okay, right? So what is the job of slave? The job of slave is to store the data. Okay, store the data file. So let's say this is a big file here, very big file of 20,000 records. So 10,000 will be here, 10,000 record will be here. Okay, 10,000 will be here, right? And 10,000 will be here. Let's say 40,000 records are there and they are kept on the slave node. Master doesn't keep the files. So when master gets the file from the external system, what it does, map reduce concept, partition, breaks it. Once it breaks it, it sends it to the respective slave. Now, master will have some rule. Okay, he will send an instruction to slave machine, do this, do this. It's like a class teacher telling what to do. The job of Yarn is same, yet another resource, yet another resource negotiator. What it does, it tells the slave what to do, right? It doesn't do on its own, it just provides the direction how to be done, what to need to. So if this has been given to him, he would be told that, okay, this is a map reduce program, you take this program and run it on this data. He will give this map reduce program to them and tell them, okay, you do this, do this, do this. Everyone will do the mapping and reduction, and then once the data is completed, it sends it back to the master. Master will just collate it and present the result. Understood? So the job which is being done by master, it has one process or daemon which is called as Yarn. It has got one process inside it whose responsibility to see which slave is available to take the job. Right? If a slave is overburdened with more of the job, it will take that job and push it to other. Right? So when this system is working, you don't have one master, you have minimum of 2 masters. Why? Because backup. If one gets failed, the other one can pick it up and do. The capacity of slave machine, when I say capacity, the configuration of the machine. Configuration of slave machine is more than the configuration of master. Why? Because these are the machine where the actual processing is going to happen. So we call these slave machine as a commodity. Commodity, you understand, right? Product. Commodity has a price. So whenever you design a distributed system in Hadoop, your commodity machine or the slave machine has more powerful. When I say powerful means we'll have more RAM, we'll have more disk, will be faster in CPU core, faster in this RAM and all those, right? Master is more of a guy who just tells what to do, right? In terms of another software which we use in the organization is called a single store. Same concept, right? Single store is a product in the market which we use. Single store, this master is called as aggregator. Aggregator, you understand, right? Something who joins everything, right? Add everything. So this master, we don't call it master, we call it as an aggregator. This slave, we don't call it slave, we call it as a leaf. Terminology change, concept still remains the same, right? So aggregator negotiates with all the leaf node what needs to be done. Okay, so this is your ecosystem. You can read about other tools which is mentioned, but again, more or less, that's the whole ecosystem, right? Hadoop is an open source software framework that allows users to store and process large amount of data, aka big data. Hadoop was introduced in practice in 2011. Hadoop can operate on computer cluster respectively, it can consider data cluster. Okay. Hadoop offers a specifically organized storage of big data known as Hadoop distributed file system. Means how the data will be stored in Hadoop will be in a form of a big data. Okay, data processing is performed by a map reduce programming module. So in your lab assignment, you have to write a program. You have done the lab one or no?
Yeah.
You have tried it?
Installation has been done.
Installation done? Okay.
There is a file mentioned readme.
README, you can take any README file from the internet,
Any file.
or you can write your own notepad file.
.md.
It's a format. You can use .txt also.
.txt.
Yeah, you can use
And
it.
the program we need to write ourselves, a Python
You
program.
can get it on internet also.
Actually, it is in the instruction, it is given like, the program is already provided or something.
You
like
can
that.
search it on the internet. I will show you how it is done. Okay, today I will show you how it runs. But again, I think I have created a document for you with a screenshot so that you can refer to that how and when you will use the command. So you have to just follow the instruction and use it. Okay, but the MapReduce program pretty much remains the same, whether you're writing in Java, whether you're writing in Python. Only the syntax change, so basically MapReduce program, what it will do, it will just read the file line by line. So whether you write it in Python, so if you write it in Python, then find while the file, end of the file, go and read line by line. Once you read line by line, what is the next step? You convert it to key value pair. Take each word, assign a value. Take each word, assign a value. Value 1, value 1, value. Then you do the reduce part. See which of the value can be shuffled together and collected to a same group. And then you add it up. So it will give a word count. I will show you how to do it. Okay, program still remains the same. Again, for your class point of view, it's a simple example, but when you do a big data programming, you need to start logically thinking how you will do it. The logic of MapReduce still remains the same. Only thing will change is key value pair will change, file name will be changing, right? Because you will not get txt file in the organization, right? You will get some data file which has got many columns. So you have to just customize that program. Using Hadoop, the MapReduce data processing can be executed on multiple servers called nodes. That's a slave nodes. Hadoop is designed to operate on commodity machine, means slave machine. Commodity machines are nothing but slave machine. Okay, they are powerful machine. Performance of each single machine is getting less important, right? Because each of the slave machines' performance is less important because they are independently running. Nodes can be grouped into cluster, dispersing, processing, and memory constraint for faster access of data. So when I say node can be clustered, means this two slave can be on the same cloud. This two slave can be on the same cloud, right? So how many of you have, understand what is data center? Have you ever seen data center? Your college has a data center. Have you all have not seen? Okay. This is one laptop, right? If I keep one laptop over each other, this becomes a rack, right? So library you have seen, right? How library is designed? You will see rack, aisle, right? Each aisle will have sections, right? Each section will have a book. Instead of book, you just put a computer inside it. So the smallest computer is this much thin. This is a small computer, if you see, right? This computer will have a memory disk, it will have a RAM, it will have a core processor, its size is this much thin. You put like this hundreds of it, like a book, that becomes a rack. So if they are independently existing, then it's a rack. Now you take a network cable, you understand network cable, right? If you take one network cable, push it inside each other, they are all connected now, right? If you connect all of them through the internet, that becomes a data center. And the data center, when you talk about cloud is nothing but a data center. A huge amount of physical machines that are kept in one location is called as data center. Like I'm oversimplifying it, but try to imagine it is like you will have data center in, I think in your this floor only, it's there. So then you will see a lot of machines that are kept. Since its data center is locally hosted here, if it is not hosted here, if it is hosted in Germany, then it becomes a cloud, because you cannot access machine in Germany. You have to access it through remote machines, right? So you have to connect through internet and access those machines. So those data centers are connected to each other, and when there is a failure of one data center, you read it from other data center. So there is one thing is happening is a lot of big cloud providers like Azure, your Amazon, Google, Microsoft, they're building huge data centers. So they are in every country, they are building huge data. So basically they're taking an office. In the office, they are keeping huge hundreds and thousands of machines together in a rack, and they are connecting it through internet. And somebody needs a machine for a virtual machine, or they need a machine to do their software development, they rent it. Basically, they are renting those machines to access those and use it. Google has also made a data center under the Pacific Ocean. It's a huge, like almost like a 10 oil tanker size. It's a cylindrical shape. If you see, Microsoft has also, they are connecting that data center under the Pacific Ocean and keeping all the data. If something happens, they don't lose data. Google has done it, Microsoft, they are bringing the data center every 10-15 years up and then recharging it and then bringing it back. So it's a huge data center, right? So cloud-based processing helps to improve scalability and reliability. In case of problem in one cluster, processing can be moved to process into another cluster, right? So if there is an issue with one data center or one cluster, they can move it to other one. Hadoop divides large file into blocks and store them in different cluster nodes, thus making system highly fault tolerant. I told you one file is distributed to other. So now let's say I gave you an example. This is one file of 40K records. So 10 is gone here, 10 is gone here, 10 is gone here, 10 is distributed, right? You divided the file. But let's say this node goes down. So you lose that 10 data, right? That's gone, right?
Yeah.
So in order to make leaf node or the slave also reliable, they keep copy of each in others. Right? You need, right? So let's say this is a 40,000 file. You do a map reduce, you split the file, one file goes here, 10K. One file goes here, one file goes here, one file goes here. Distributed. Everything works fine. Suddenly this node goes down. Then you can process this, but not this. So your aggregator needs this data, right? So what you do is normally in distributed environment Hadoop system, you keep the copy also somewhere. So that if one goes down, you can reliably go to other and pick the data from there. So slave is also multiple copies are built. Okay.
That is the processed data, right? Copy
That's the
of
unprocessed data.
unprocessed.
Yeah. Think about it now. Let's say, for example, take example of the class. There are 10 students and I have 10 questions and 10 answers, right? I give each of them 1, 1, 1, right? Now I say exam is completed, give my copies back. One guy left taking his copy. What will I do? Is the exam completed? For me, it's not because one is missing, right? So in order to make everything reliable, what I will say, I will give two copies for each. So I give one copy to the person and I give same copy to other person also. In case this person goes, I can pick it from the other one. It's basically making a replication. It's called as replicating a data. So that one node goes down, the other node can give the data and process the data and give it to me. Okay. Hadoop can handle very large data set in the range of gigabytes or terabytes or even petabytes. Data from the input stream can never be changed. The write once model is used. Okay. So Hadoop uses a concept called as write once. Write once means you can write it only once. When I say write once means you don't write it multiple times. Okay. The write one model that assume the data never changes after it is written simplifies replication. So if you have written a data in one node of slave and you want to replicate to other, it has to be exactly the same. Otherwise, there is no replication, right? If you change the data in one place. Thanks to this model and to the independent parallel processing, data throughput speeds up. We'll see, like, you try to logically understand it. I know it's a very different subject from the regular course you study, but this is the way you need to go forward if you have to work on data analyst, data scientist, or AI. And this has to be learned. There is no other choice because as the industry is going. Okay. The high level of architecture of Hadoop is the processing model works on the data locality where computation logic is sent with the data to the nearest cluster node. So read this. The processing model works on data locality. Processing model works on data locality. Where is data located? In the slave node. So processing happens here. Data is stayed in the local slave, right? Where the computation logic is sent with the data to the nearest node. Computation logic, what needs to be done is sent by this person. So this is simple like a dummy. This is a very efficient machine, but doesn't know what to do. This is the machine master node, which know what needs to be done, but doesn't have a capacity to do it. So the job is The worker, these are workers or slave node. They are very efficient, but they don't know what to do. All the direction needs to come from here. Okay. So Hadoop core is composed of three components. Hadoop distributed file system. Hadoop distributed file system means files that are stored across the nodes or so there are, we will use the terminology. This is called as master, right? So we will call it as name nodes. Okay, it is called as name node. Hello? Hello? Yes, who's there? Can we talk after some time? It's regarding what? Yeah, I will connect with you later on. Right now, I'm in a meeting right now, okay? Thank you. Okay, so Hadoop core component has three components, Hadoop distributed file system. So I was saying master is called as name node, okay? Slaves are called as data nodes. Okay, again, when you go in industry, they will be calling with different names. Okay, this is the standard name. If I use another software, they may be calling it as aggregator and leaf. There may be somewhere it is called a master and slave. So the concept still remains the same. The terminology changes, right? Master is called as name node. Data is stored is called as data node. Okay. So Hadoop distributed file system. Hadoop core has component composed of three components. Hadoop distributed file system means the data is stored in different files of the slave. It has got a map reduce program. Map reduce is here. Program is here. When it has to be executed, the program instructions are sent here and it executes it. Master never executes on its own. Okay. It tells what has to be executed and how it has to be executed. The third one is called as yet another resource navigator or yet another resource negotiator for Hadoop. This is the program, this is residing here, Yarn. What is its job is to monitor which slaves or data nodes are free, which can be used, which are up and running, which are offline, which are overburdened, which are less burdened, how to distribute the load and all this stuff. This process manages it. Yarn was later introduced after Hadoop 2.0, if I'm not wrong. Before that, Yarn was not there. So the problem was, how would we manage the resources? Because many times some of the leaf nodes were crashing and all those things. So there was some process a daemon needed to manage and orchestrate how the client slave will work. The concept of master slave architecture is implemented to organize data processing and Hadoop distributed file system data stores. Okay. So this is a Hadoop architecture. So if you see, this is a master node, right? Red one. This is a slave node. So either you call this as a name node or a data node. You can call it also. Okay. So Hadoop distributed file system layer is there and a map reduce layer is there. Whenever a job comes, okay, so I'm just trying to explain you at a very high level. Okay, we'll go into the details. For as of now in this diagram, whenever a task comes to a name node or a master node, what it does, it gives a task number. Okay, it will give a task number because it has to identify, right? I'm giving A, B, C, D, X, Y, Z tasks. So it has got a task tracker. So if you give any assignment, you have to track it, right? How much it is completed or is closed or it started or not started. The job tracker, each of the job will then given to each of the slave nodes, right? So let's say job name is job 1. So job 1 is given to this, job 2 is given to this node, right? Now this master node will track how job 1 is performing, how job 2 is performing and continuously checking whether it is processing it or not, right? Name node will connect with data node to see whether the data exists or not on those, because job will run the job on the data, right? So it has to also check whether the data is residing or not. Is the data already there or not, right? Your map reduce process is split the file. Once you get the file, master node will split it. It goes to each data node, right? Now each split is there in the data node, right? How do we know that the data is residing where? Think in this way, if I give you, let's say you are working in a big warehouse, okay? And you are in the front door, right? And somebody comes you and give you let's say, a huge truck came with lot of items in it, right? Now, you would have seen it in practical also, right? So let's say the guys are unloading it. And a huge warehouse is there to put the items. What will you do? How many of you have done your relocation of your places? Have you all done shifting? Everyone did, right? You all do this. I will explain you how. Let's say your mover came to your home, you give all the packed everything, right? You give it in the truck. Truck takes you to the destination. Now you stand in front of the gate. Why do you stand?
So
Collect them.
To collect them, right? If you are not standing, what will happen? Item will be lost. So same thing Hadoop file system does. It stands there to see what? The incoming data, incoming file. Now the data is coming. The boxes are coming. What do you do?
collect,
Hmm?
collect to see if
There are 100 boxes coming for your move after move, right? They are bringing one by one. What are you going to do? It's not segregated. It's just coming, right? Boxes are coming. What normally you do?
put it in somewhere.
Put it in somewhere.
Arrange them where they're supposed to.
Does it auto arrange?
Hmm.
Let's say I am a guy mover, you are coming in front of the door, I come with this box. What should I do with this box? What you are doing? Telling me.
To see where should I put it here.
Where should I put it? Why you ask him, why do you tell him where should you put?
I can arrange the boxes.
Tomorrow, when you want to find it, you can find it, right? If a boxes are coming one by one, you will say, okay, keep this box in upper room. Keep this box in kitchen, keep this box in basement. What are you telling?
Location.
The location. Why you want to tell him the location? Because when you unpack it tomorrow, you know where to find. So same thing if you are doing right now in a memory, if I tell you take a piece of paper and start writing box 1, okay, keep it in kitchen. Okay, box 1 in kitchen. Box 2, okay, keep it in basement. What are you doing? You're writing where each an item is getting stored. Same thing is happening here. If the files are coming, how would you know where it is residing? So you need to keep a track of it, right? Because it's storing in many slaves, right? Who will keep a track? Name node will keep a track. Which data node, which slave node the data is getting stored, because these are partition data, right? Broken down. It's like a boxes. Where it is stored, what is the location, which slave, which rack, which data center, which all those stuff, right? Which cloud it is there. Because you are thinking of your one house, think about a house which is a whole world. Your data is distributed across hundreds and thousands of machines. How would you know where the data is stored? And what fraction of data is stored where? Someone has to keep a track. So name node keeps a track of data node where the data is residing in the cluster. Understood? Now, this is the part of data storage in Hadoop file system. How would you do a map reduce? So once you put the data inside your home, now somebody comes and says that, oh, can I get the utensils? What do you do?
Go to the kitchen and unbox.
How do you go to kitchen? Because you memorize that I kept the box of utensils there, so I have to go there and pick it up. Is it illogical? If I tell you don't have a memory, you have a pen and paper where you have written all the things where you have kept, you can quickly check it, right? Oh, go to this place, you will find the box number 1. So you'll go there and pick it. The guy who comes and pick it up, whether did he went there to pick it up, did it pick it up, did he find it, did it go out? Who keeps the track? You keep the track. That task that is called as task tracker. If a map reduce program has to be run on the data location, means the person who is going to find the box, do the processing of the box and taking that box or whatever he wants to do, who will keep a track? You will keep a track. Same case, master node keeps a track ID of the job that is submitted to data node, how these are processed and how and when they will get completed. It has to be kept here. Why? Because if the job is not completed, the master needs to know, right? So that it can rerun it or it can rectify it, it can check it. Someone came to your house and said, oh, I want to get this box. You say, oh, go in kitchen and you will find it. That guy is searching and couldn't find it and left home. You should be keeping a track, no? You constantly ask that person, did you find it? Did you find it? He doesn't find it, okay. You don't find it, go to this slave or go to this location and find it. That whole thing is being tracked under job tracker. Now you understood how it is work? You need to start visualizing with an example how it is
So
done.
job tracker is the entire thing and task tracker is like the partitioning, right?
Task tracker is more of tracking how the work is being progressed. And this name node job is to identify where the data is residing. This tells you the location, this tells you the processing status. Right, whether the job is completed, failed or not started, all those things will be collected in the task tracker. Okay. To HDFS architecture, two layers are present. One is called a HDFS layer, responsible for data. Right, this layer is responsible for data, and MapReduce layer is responsible for data processing. So this person, HDFS layer, will be trapped in the name node. Its responsibility is to keep a track of where the data is there. So if you have a big file of 40K, you split into 4 data nodes. Each data node has got 10 records. This name node should have that information. Right? It should have information. Okay. Slave node 1 has got the first section of file from 1 to 10K. Slave node 2 has got a file from 10,001 to 20,000K. Like that. So that if any job comes for MapReduce program, he can say that, okay, this is a job to do a MapReduce program to find and split the data, combine and shuffle the data to get an output. This tracker will send a request to the slave node saying that go to the node slave node 1 where the data node 1 is there, data node, process that MapReduce program and give me the output. Say the job will again go to slave node 2. It will say, oh, you have the data rate 2. This is a MapReduce program, run on that data and give me the output. So each of the slave node will process that MapReduce function program, give an output, and it will go to give the status here that yes, it started, it running, it completed. Once it is completed, the output will be shown here. Okay. Split in data is split into blocks and stored in distributed manner, right? Data node, each of them is split. HDFS runs two daemons. Daemons are nothing but processes, name node and data node. I told you there are two, name node and data node. Name node run on master node, data node runs on slave node. So this one, two process, name node and data node, right? Name node run on master. Data node is reported, information is here, but this data node is running here, right? Data is residing here, right? So think about it, it's like a box, right? You keep a track where the things are, right? It's like a very simple example would be, it's like an index of your page, book. It's an index of your dictionary. So if I want to search a letter which starts with R, rain, then I will go in the dictionary and search for R alphabet and then go to that page, right? Same thing, the index portion is this. Where is your item and which location it is? So that information is there. Where the data is stored on the slave nodes, right? All the actual information. What all job needs to be run on those data nodes? Program is here, but it is not running here, it is running on the data node. Instruction is sent to the slave. Name node runs on master node, data node runs on slave node. Data node is actually responsible for storing business data, right? Data node is responsible for storing the data. In typical deployment, there is one dedicated machine running name node and all other nodes in the cluster run data node. So one is master and all other are slave. Okay, this is not practically possible because if you keep one master node, if it fails, then there's a problem, right? So you keep the replication of master and replication of the data node also. Okay, so this is the structure. Master node has got name node and resource manager. Resource manager is nothing but a yarn. Okay, yet another resource negotiator. So if you draw in hierarchical format, so master node has name node, resource manager, which tracks the usage on each of the slave node. Data node is the slave node, which has got data node, node manager. Node manager's job is to specify how this particular node is performing. And whatever is the information the node manager has, it sends to the resource manager saying, if this is a node manager and this is a heavy utilize. So it will say 100% CPU utilization. It will report it to the resource manager saying that I'm 100% utilized, I cannot run. Right, so all the information, it's like a monitoring your own machine. But the information of your machine is reported to the master nodes. Map and reduce programs are sitting here, right? When I'm saying map and reduce, it's not running until unless master node gives the instruction to run it, right? It's a small program, right? It can be of 100 line, 200 line, 500 line of program which is sitting, not running. It will only run when the master node sends the request to run it, then only process it, okay? HDFS has a master slave architecture. It consists of name node. Name node is known as master node. It manages the file system, namespace, and execution operation like opening, closing, renaming file and directories. It maintains the file system tree and the metadata, number of data blocks, replica, etc. You understand the word of data and metadata? Do you know that? What does it mean?
Data is like data about data.
Yeah, I know data about what you call it? Data about data, right? Okay, so let me make it easier. Metadata. Data you understand. So let's say there is a table called as in a database, or let's say I will give you an example of your metadata. You are storing everything in your CD drive in your disk, right? It's stored as an Excel file is a data. So that file is called as data. Where it is stored, which location it is stored, which machine it is there, what is an IP address of that machine, everything is metadata, right? So data within data is called as metadata, right? So data in isolation is just a data, it's a number or text or string, right? But where, how, when, so metadata can be like, is the data only read only or is it read write? That's a metadata combination, right? The name node also maintain and manages slave node blocks, block size, which is the minimum amount of data that can read or write. Files in HDFS are broken into block size chunks, which are stored as independent unit. The default size of the block of HDFS is 128 MB. So the diagram which I showed you, right? This one. So I gave you an example, 40K data, each are broken down into 10 each. What should be the size of this? It varies, right?
Yeah, depends
It
on
can
the
be
slave.
15, 20, 50, 30, right? It can vary. That grouping of each of the data segment is called as a block, right? So it depends what is the block size you have set it up for your configuration. Is it too big, too small? Depends how many leaf nodes are there, how many partition you need to do. All those configurations are set up by Hadoop distributed file system, okay? The file associated with metadata are file system image, the persistent checkpoint of file system metadata, edit log, it contains all the recent modification made to the file system with respect to most recent file system image. File system image is not your picture image. Okay, file system image is your disk image or a drive image. So if you see, basically it means that location, sector, disk path, address of the memory, and all those information is called as file image, file system image. Okay, it's not an image or picture, it's a formatting of the data. The architecture of HDFS data node, also known as slave node, it performs read and write operation as per the request of the client or the name node, and it reports back the name node periodically with list of block that is in it is storing, right? So the master store keeps all the track. Secondary name node usually runs on the separate physical machine. Its role is to merge the file system image and edit log for name node periodically. This prevents the edit log from becoming too large. It also stores a copy of merged file system image into persistent storage, which can be used in case the name node failure. Basically, it's a master node. So basically name secondary master node or secondary aggregator or fallback you can think about. We always have two master. If one fails, second one can kick in. Normally second one is in. So something that is one thing is called as active passive, active active, passive passive, and passive active. Active means both are running in a full live condition, right? Both the nodes are fully operational. They are taking the request and processing it. Normally in this production, you will have one active, one passive. Passive doesn't mean it is switched off. Passive means it continuously polls the active. Polls means continuously pokes the active and get the latest information, right? So anything that is being logged in the active, anything that is running on active, all this history, all this logging event, everything is captured and kept in the secondary master. Why? Because if suddenly master nodes goes down, this can become master and start running and supporting it. There is no downtime, right? So it will prevents the edit log, and if the master log is node is logging lot of activity, means writing lot of log files, it will just start sending it to the secondary master, so that tomorrow something happens, edit log can be reviewed to see what has happened, right? From Hadoop version 0.210 onwards, the new type of name node called as backup node was introduced to maintain up-to-date state of the namespace. It helps in restoring the data faster. If your master goes down, so secondary name node helps into restore the system. Okay. Is it valid or not, right? So if your master goes down, everything, you cannot stop everything. You need the business to operate as usual. So if everything is recorded and kept in a separate copy, right? So think about this way. If your computer is logging all the events, right? And suddenly your machine got crashed, what will happen? You're not able to boot it. What are you going to do?
Fine.
You will reformat it, but your data is lost, right? If I tell you there is a system where you can go in your home, like I have done in my laptop, I have created an image of it in the cloud, right? I created an image in my cloud. What will happen if my laptop gets crashed? What will I do? I will take an image from there and download it. By the time I'm not using it, I can go to the image and start working with the image to work it out. But I'm not doing any processing. Think the same way industry is working, where if master is down, the image is there and logs are there, they can run as a normal user till this is coming up, right? So same thing happens, right?
I want to ask, is if the master is down and I'm using the second name node, and will I shift back to the master one, or I keep on working on the second?
It depends what is the strategy for failover. So what we do is, normally I will give you another example. We have two data center. One is GCC and other is SCC. So GCC is my production and SCC is a fallback. So if any production issue happens, right? So normally what we do is, so let's say today is Friday, assume today is Friday, and there is a new code deployment happened, right? When the new code deployment happened, we don't touch production. We let it go like this. We take the failover and we use a Friday end of the day, because Sunday and Monday, Saturday and Sunday, not much traffic is there in the system, right? We take this backup or the secondary node, we bring this first down. When we bring it down, we see what is production hits, which is running live, right? We don't want to rest, so we monitor it, that is everything fine there or not. So if the volumes are very high, we never bring it down. If volume goes down, there is not much of traffic, we know that machine is very powerful, it can sustain that much of load. We bring this down and deploy the new code. When I deploy this new code, and then we test it here. We test it, whether the new code is working fine or not. We test every few of the production user account and everything, because it's also connected to the live system in the down, right? We test everything, but we don't put load on the system, we just test it. Oh, everything is fine. Now what we do is, when this one is updated copy, this is one is old copy, right? We switch it over. When I say switch it over, it happens in fraction of second. As a user, you will never know it. So what we do is, since the traffic is coming from load balancer, we just say go here.
Yeah.
So you will not even feel that there is a change. So you just refresh a page, a new page will come.
Okay.
Now every traffic is routed here. The one which was earlier production, we bring it down and then we deploy the code. Till the point when the new code is not coming up, we let everyone to go to the secondary. Once this is up, we then move it back to the production. And then use this again for the new code.
So they
Right.
just like.
So if you see 5-6 years back, 10 years back, you will see that, oh, deployment like many of the website will say, you cannot access this activity from maintenance will be there from 12:15 in the night to 2 o'clock. Nowadays, you see, very rare, until unless there is a major change or issue, right?
Yeah.
Even if there is a maintenance, they will take for 15 minutes.
Yeah.
That 15 minutes is only useful to switch it.
Oh.
Normally, it takes 1 minute, less than a minute.
Uh-huh.
But we keep a window of 15 minutes. If something goes wrong with the server is not kicking in, we have to restart and all those stuff, right? Okay. It's a very interesting topic, I will tell you. When you start seeing in how it is done in the organization, and that's why I say, I get calls at 2 o'clock in the night and I have to pick it up,
Wow.
right? When the production support goes, I will be in the call for 18 hours non-stop, because you don't know what's going to happen, right?
Yeah.
So it's interesting, and it's still more of a stressful also to see if the data get lost. You think about this is a financial data. You cannot say the data is lost. There is no 99.99999 chance that your data should not get lost or corrupted. I don't know, you all have heard about CrowdStrike. Did you hear about it? Anyone knows what happened? What happened?
They released an update. Maybe that update is not tested properly. And
So what happened?
blue screen of death.
Yeah, that was an outcome. So basically what happened, it was targeted for Microsoft cloud systems, okay? Microsoft cloud, who all have purchased it? Across the globe, right? Boeing has purchased, big Air Canada purchased, RBC purchased. More or less every big organization have their server hosted on cloud, correct?
Yeah.
They have their server hosted on cloud, their application, their databases on cloud. So CrowdStrike is a package which is for network security. It was more of securing from hacking. Okay, so there was a package that was to be updated. It's like a not an antivirus. Think about it's an antivirus thing which was supposed to be pushed in all of the Amazon 1 million cloud servers. It's a package, right? It's like a small package you get, right?
Yeah.
Windows install update package. It was something like that, a small package that needed to be installed on cloud virtual machines or the cloud machines. They eventually said that it was done by a junior engineer who developed this and he pushed it. You cannot do like that, right? A package goes through a lot of approvals to get it into production. You cannot say, oh, somebody pushed it and it went to production. No, it. So this package was supposed to be deployed as part of a regular update of Windows, right? So automatically you see when you restart your machine, it says new package installed, right? It was something like that. When we deal with cloud, right? So why did we go to cloud? Because we want reliability, right? Because we cannot manage so many servers. So we said, okay, we'll host the servers in the machine. So Microsoft agreed with all of his client the reliability and uptime of 99.5 times 9. 99.99999. That's the reliability percentage they are offering. Means you can have 1 second downtime in 10 years. That's an agreement between client and Microsoft, right? The downtime was 6 hours. 6 hours. Think about how much penalty we would have asked to give because we never moved to cloud. Cloud came to us, right? Microsoft say, oh, buy our product. It's very reliable. How will you manage this hundreds and thousands of servers? Come to cloud. We offer you a reliability of 99.99999. That's huge, right? 1 second failure in 10 years. 1 second failure is hardly, you can visualize it, right? Means one transaction gets failed, maybe 10 in 10 years. That is the rarest of the rare, right? That's a reliability. That's why we are paying it, right? And if you have a package and that resulted in a downtime of 6 hours, how much billion of dollars have been lost? Think about it. Boeing was not able to invoice his client, get the money. RBC, online banking was dropped. Air Canada, all the online bookings were stopped. American Express, all the delivery was this DHL and FedEx, all the everything is happening through internet, right?
Yeah.
All your package scanning, distribution, everything is going. 6 hours, what will you do?
Sit here.
Nothing, right?
Yeah.
Who is going to pay? And that's the reason the CrowdStrike went up to massive scale, right? And they have to pay penalty of billions of dollars to get that. Because who will bear the loss? If I am losing a business for 6 hours, somebody has to pay it, right?
Yeah.
I'm not able to access my data. You are saying your blue screen is coming. What will I do? We never told you to deploy the package. You only deployed it, right? So then they reverted it and then they restored it, but the loss was done, right? Hadoop clusters are built on concept of Hadoop network topology. Important is the concept of computer system commodity, which assumes the possibility of utilize any computer as long as it has incorporated Hadoop resource management system YAM. So if you see on the right hand side, oh, there is no image shown here. Okay, that's the next page. You see this? I was explaining this. This is a data center. Right, there are racks and all these machines are getting connected. Okay. Huge Hadoop file system instances run on cluster of computers spread across many racks. Right? Huge computers are there in racks. The communication between the nodes on different racks has to go through switches. Switches and routers are used. Okay. Mostly the network bandwidth between the nodes on the same rack is more than that between a machine and separate rack. So it is like if I ask you to select a book on the same rack, for you it will be faster, right? You can pick. If I say one book is on rack 1, another book is on rack 6. So you pick 1 and then go to 6 and pick it up. The time delay will be more. So same concept goes here. The communication between the nodes on different rack. If the node means the machines, the slave nodes are on different rack, there will be a latency. But if they are on the same rack, the read of the write of the operation will be very fast, right? But again, you don't know when you put your data in the cloud, you don't know which rack where it is, right? So normally the concept of putting the data on the data center is through, which is called as geographical area, right? So if I have to put the data, so if I'm in Canada here in Toronto, so we kept one data center in Guelph and one data center is in Toronto. So the time delay is very minimal, right? But you will have big organizations which are huge ones, right? Amazon, they are storing the data center across the globe because they don't want the data information to come from US versus the person sitting in Japan, right? The delay will be huge, right? So they will have the data locally in that data center. Okay. Hadoop cluster consists of data center, rack, and the nodes which are actually executes the job. Here the data center consists of rack and rack consists of nodes. Network bandwidth available to process depending on the location of the processes. That is, bandwidth availability become lesser as we go far. If the data centers are located far apart, the time to retrieve the data from two data center will be more. Process on the same node will be faster. Different nodes on the same rack again will be faster. Nodes on different rack on the same data center still be faster. Nodes on different data center will be slower. The slowest will be if you keep one data center here in rack 1 here and you have another data center located in UK, London. So if you have to take the data from here, it will be faster, right? Two nodes are still here, they can pull the data quickly. But if one data is here and another is in UK, then the processing of the master will be slower because it will pick up the data from here quickly, but it will take long time to pick it from there. So when I'm saying long time latency, we are talking about latency of like 800, 900 milliseconds. Okay, don't think about 10 seconds, okay? It's very fast. But people don't wait for even 900 milliseconds. Topological arrangement of the network affect the performance of Hadoop cluster when the size of Hadoop cluster grows. In addition to the performance, we also need to take care of the high availability and handling of the failure. This is like which I told you, production versus backup, right? In order to achieve this, cluster formation makes use of network topology. So basically we use a clustered bit system where multiple active, multiple passives are there. In Hadoop, a network is represented as a tree and distance between the nodes of the tree is considered as an important factor for formation of Hadoop cluster. Hadoop cluster, I told you, think about a data file stored in different locations, right? That's a Hadoop cluster of data stored in different locations. The farther the node, more the time. The closer the data residing locality, the faster the response. right? Here, the distance between two nodes is equal to the sum of their distance to their closest common ancestors. So you know the tree structure, right? Again, people have to start. So as an IT professional, I would suggest everyone to spend at least 2 to 3 hours reading every day. You have to read it if you're I will tell you what I do when I go home from 11 to 1 o'clock in the night. I just read. That time I cannot share with anyone. So you also all have to, if you want to survive in IT, you have to read it. There is no choice. So you know tree structure, right? You studied B tree, right? C++. So tree is like this, right? Like this. Tree is like this, hierarchical tree. So this is your master node, right? This is sub master node, another master node inside it. So it says the distance between the two nodes, the last line, the distance between the two nodes is equal to their distance to the closest common ancestor. Who are the closest common ancestor? This is the closest common ancestor. So the distance between these two will be the distance between the two closest ancestors. That will be the shortest distance. So when you keep your data, you need to keep a data node in a way that it is closest to the nearest master node. Again, it's more of a theoretical, I explained you, but it is more complex than this. Okay. There is no diagram when you do this big data study. You have to start imagining and you have to start programming it. Okay, it's not like simple, which I showed you. I tried to explain in a simplistic way that the B node is your nearest ancestor for whom? F and E. That's the closest ancestor. So you need to keep your data to the closest ancestor for each other. If they are closest to the ancestor, the data should reside in the same node or the same rack, right? Or the same data center. If they are farthest apart to each other in different data center, the time will be more. Okay. Configuration of cluster is critically important from the perspective of HDFS performance. Your performance will get impacted if they are in different location. Apache daemon needs it to support nodes may run on same machine or in different machines subject to configuration of cluster. So master node can run, master and data node can also run on the same machine. The master slave configuration which I showed you, it can run on the same machine also. So like your lab assignment, you don't have 10 machines, right? You will run your master and the data node on the same machine because it's a theoretical class, right? Because you are doing something which has a lab assignment. So it is fine, right? If you want to do a map reduce program, master residing on your same machine, data node also on the same machine, no problem, because your data is not huge. But it can be done. But it is not practical feasible when you go in the big data. Single node cluster, which I told you, which is the one which you will do as an assignment. Your master will also there, data node will also be there. You will run the map reduce program on the same machine. Everything will happen the same, right? That's a single node Hadoop cluster. All the daemon like name node, data node run on the same machine. In a single node Hadoop cluster, all the process run on one JVM instance. So when you do a lab assignment, you have not got 10 machines, right? You have only one machine, right? So you do everything on the one machine, right? The user need not make a configuration setting. The Hadoop user only need to set up Java Home, because when you do the installation of Hadoop, you need to set up Java Home path. The default factor of single node Hadoop cluster is 1. So you will have one master, one data, both residing on the same machine. Multi-node cluster, in multi-node cluster, the daemon run separate host or machine. So the master is on a separate machine, slave is on separate machine, right? The multi-node Hadoop cluster has a master slave architecture. In the name node daemon run on one master machine, the data node daemon run on the slave machine. It's separated, right? In multi-node Hadoop cluster, the slave daemons like data node and node manager run on less powerful machine. On the other hand, master daemon node, name node, resource manager run on a powerful server. In multi-node Hadoop cluster, slave machines can be present in any location, regardless of physical location of master. So your master can be in Toronto, but the data can be residing anywhere, right? So you can read it. HDFS communication protocol works on the top of TCP IP protocol. The client establishes a connection with the name node using configuration of TCP port. Hadoop cluster establishes a connection to HDFS client using a client protocol. So when you install Hadoop and launch it, it will run through a certain port number. Okay, so I will show you how to. Data node talks to name node using data node protocol. A remote procedure call abstraction wraps both the client protocol, data node protocol. The name node does not initiate any RPC. It only responds to RPC from the data node. RPC, you know, remote procedure call. How many of you have heard about this word? RPC? Nobody heard it? Remote means what? Remote means what? One is near, other is remote. What does it mean?
Far away.
Far away. Remote means far. Procedure means? Procedure. Procedure means procedure, like if you studied, have you studied C? C language have you studied? Python you have studied, right? So procedure is nothing but function. Okay, so in C it is called a structure and procedure. In C++ it is called as function. Name is called function. In Python also it is called function. Procedure and nothing function. Call means something that is triggered. I call that person. Means you are making a request. Call. A remote procedure call. How would you understand it? Something which is far, which is a function which you are calling. That's a remote procedure call. I give you a practical example or simplistic example which I studied when my engineering in 20 years back at RPC. Let's say I give you 5 plus 5. You give me an answer 10. Now, if I tell you 5 plus 5 is happening in your machine, but the 5 plus 5 data is sent to somewhere where the actual addition function is written. So that function will add your result and give you the result here. So that's a remote procedure call. Right? Other example will be, you have written function in any of the language, right? You pass an argument. Have you seen something like this? Again, I don't know if you all, it's a lot long here, right? So I'm just writing a simple program in C. Okay, C function has got main, right? Right, like this you write. Within the main function I write add integer A, comma, integer B. Right, and I will give return as integer add function, right? Return value, right? And I close the main. Here I will explain integer add, which takes two argument, integer A, integer X, integer Y. And within that function I will write integer Z equals to integer X plus Y. And I will say return Z. And I close the function. Here I will write print. Let me add something here. Let's say here enter first number, right? So you enter by the user, okay? Let it called as A. Enter second number. This is B, right? Then we call the add function. Then you write C equals to A plus B, and then print C. You understand the program? What I'm doing? The C function will start from here, main. It will ask you to enter the first number. So you entered 5. It will ask you the second number. You enter 4. Then this function is called add. What is going to do? It will take two arguments, A and B. My A is 5, B is 4. Where is function explained? Outside. This is main, right? This is the main function, right? This is written outside, right? When you call this function, it will go here. Instead of X, it will put 5. Instead of Y, it will put 4. What it will do? 5 plus 4, 9. 9 is calculated. Now 9 is returned here. This function which is called outside is called as remote procedure call, right? Remotely getting executed. If you remember C++ or C, there is something called as call by reference, call by value. So it's something like that, okay? You should read these things, okay? Data flow in HDFS is a blog, you can read it. I will just go through one important aspect. The client wants to perform processing on the data in Hadoop cluster. First, the data is to be stored in HDFS. I told you Then the data processing program MapReduce will be initiated. Data can be read from HDFS file or written to HDFS file. The new data file must be created one-time writing concept. I will show you something which is anatomy of read. How the read happens in the HDFS file system, okay? So this is the step, okay? It's simple, you can read it. First of all, how it happens? Your data is sitting here in the data node. Now you want to read the data, right? So how will you read? The client comes to HDFS client, means you and me, okay? Request it, right? Think about the same example I told you, you have made your house shifting, you kept all the boxes in your home. This is a new person coming up. He knocks the door, distributed file system opens a connection. Because it has to connect to this data, right? It opens the connection, right? It checks with the name node. What is name node having? Name node has having the location where the data is residing. It has got all the data links. It knows which data center and all those stuff, right? It knows it. Once it gets here, opens the connection, it validates whether the user is allowed to see the data or not, right? Not everyone can come and see the data, right? So once the connection is open, it checks everything have happened, get block location, what is the address where the data can be found. It's like a index or a dictionary's first page or a book's chapter index. So it gets all the information if it is entitled to view. It goes here, then it sends a read request to DFS file input stream. It asks to read it. Now it has got access completed. Now it's authorized to read it, it sends a read request. Once the read request goes, it goes to all the data node on this location which has been provided by the name node to him. Right? So basically think about it, somebody comes to your house and says, oh, I want this box. What are you going to tell? First tell me your name. Are you able to view it or not? Who are you and all those stuff. Then if you are okay and verified that person, what do you say? Oh, go down to the kitchen there. Below the shelf number 3, the data is there. That you will say, right? Now, once he gets the address, what he does? He takes that address and goes down searching for it, right? So he says, oh, kitchen, 3rd block, 4th cabinet, bottom location. Goes and reads it. Once he has read the data, it has got the data, it comes out and he says, I'm going. So when he's going, it is basically sending a close connection. Understood? This is the way data is read. Okay. How the write happens? This is a read, right? Read was simple, right? You go and check. Write also happens in a similar way. First, connection is created. Create a connection. So, are you allowing everyone to write it? No. You restrict it. So, first, the HDFS client says create a connection. So, it creates it, goes here. Authorization happens. So here authorization mechanism is used. The mechanism like Kerberos. There are SSO authentication. Lot of authentication validation happens, whether the user is the right user, whether he has privilege to see this data and all those stuff, right? Once the authorization and things happen, instead of read, write transaction is requested. Now I want to write the data. When the write is happening, what happens? What will happen? Name node will coordinate with this data output stream and decide where to write. This guy doesn't know where it is writing. So if you are trying to write into a distributed file system, you don't know which location it is writing. It's the name node will find which data node has an available space. Which location of the data node, when I say location means it is which cloud, which rack, which disk, which node has the data space available, write it there. So it takes that data, goes down and write into the packets where the locations are available. So when the data is written, right, 2 things can happen. One, while writing, the system connection breaks. It can happen, right? This guy should keep the track. How much has been written? Which portion has been written, what was failed, so that if it has to retry to write, it doesn't want to write whole thing, it will write the remaining ones. So it's like keeping a track, keeping a policeman standing there, oh, write it, and continuously monitoring it. As soon as there is a problem, it says, okay, stop here. Now we'll start from here, right? Whenever it is writing the packet, every time it is writing, it is acknowledging it. Yes, written, next, acknowledging it. Because if you keep on writing and suddenly breaks, you don't know where it is lost. So every time when the write initiative is happening on the data node, it keeps on updating the master node saying that yes, written, done, flag is there. One flag and check condition is there that checks every time the packet is written. When it is writing in the data node, it is not writing in one place, it is writing at multiple locations. So if there is one file, it will be written at least 2 or 3 places. So that if one got corrupted in the data node, other 2 are secure for me. It's keeping a copy, right? Once every data node has been written with the same set of data and synchronized, then it says everything is done. It sends an instruction saying that complete. Once the instruction is completed, connection is closed. Or connection is closed and the status is sent as complete. So how it is done in production, this is the picture diagram. Think in this way, how it is done in organization. You get a file. Once this file is come, there is a check there that whether this file can be loaded into a database table or not. So these data nodes are not a file loader. It's a database also. Small tables are there basically. It's a database schema structure with that table and columns. Now, once the file arrives, right? Now the file has arrived, the system first authenticates whether it is coming from a true place or not. It has to check, otherwise virus will get loaded, right? It checks, authenticity happens. Once everything is confirmed, file is picked up. If it is a huge file, it is broken down into smaller part. One chunk is taken and then seen which slave or leaf nodes are available. It takes it and put it on those locations. So when it is putting, it is not putting only one copy. It is saying, oh, you put here, you also put it as a back pocket copy. So that something goes wrong with you, tomorrow I can pick it from here. So every time when it is pasting it 2-3 places, it is acknowledging it also that, okay, are you pasting correctly? Are you pasting correctly? Are you not? Because it has to confirm, right? So when it is confirming how it is confirmed, there is something called as parity flag. So there is one keyword in the parity flag in configuration that whenever the data node is written correctly, a flag is set to true. When it is not writing correctly, it will set to false. So that report is there with the master. So it knows, okay, which one has successfully pasted or not. Once it is synced, everything is written properly. Sync means same data is replicated in multiple places. All things are done. Final message is sent to the name node saying that yes, all done, replication done. Please provide the next segment of the data. So next section is taken and then done. So this happens very fast. Very, very fast. It doesn't, the way I explain, it takes 1 hour to explain. This entire process of 290 gigs of data happens in our office every night in 2 hours, 8 minutes. That's very fast. We have 16 nodes, 16 leaf nodes with a 94 partitioning of the data nodes. Means each leaf node has 94 partition inside it. Each partition can accommodate close to like 100 gigs of data. And this is all in cloud. So it is very fast, okay? Again, these are Hadoop commands, you can read it. Okay, this is a basic get command, put command. Put command is to copy and put it into some location. Okay. That's it for today's. You all can read it. These are basic commands. Okay. How would I show you all? My laptop doesn't connect here.